cold. I can feel it through my sweater.
It was chilly, yeah. Okay, so 312. All right, so the first thing that you do, okay, so this is almost identical to when we do like remember we did the plane questions with vectors? So you had the wind, you had the plane, so you write out the equation first, and then you would arrange it so that you knew which one you were looking for, and then you would draw your vectors based on the equation. We do the exact same thing here, okay? So you start like this, your momentum before is equal to your momentum after. Okay? So in this question, a grenade of mass 1.2 kilograms is at rest. So there's no momentum beforehand. Okay? And then it says it explodes into 3 pieces. So you have M1 V1 plus M2 V2 plus M3 V3. All prime. Right? Because it's out. Okay. So it says a 0.5 kilogram piece flies off horizontally to the north at 3 meters per second. A 0.3 kilogram piece flies off horizontally to the south west at 4 meters per second. What is the horizontal speed and direction of the third piece? Okay, so I want to solve for this. Now this is the part that does have some confusion to it, but I'm going to show you which I think is a simple way of approaching it. So I have M3 V3 prime, right, is equal to. So it's equal to the negative of these two, right? Because I'm going to subtract them both to the other side. So I've just subtracted these two over here, right? Does that make sense? Now, I would have a subtract and a subtract when I move them over, right? I'm going to put the subtract on the outside of these, just like this. So what I do then is I solve for this plus this, the exact same way you'd always solve the vector question, all right? And then I'm just going to change the direction to the opposite of whatever I solve for. Does that make sense? Mm-hmm. Okay, so here's how this works. I personally like this this method here. I've always liked it, in which I showed it to you last year. We see you have 2 pieces. So we know that the first piece, the momentum of the first piece is 0.5 kg at 3 meters per second to the north. So my momentum 1 prime is to the north at, so it's 0.5 times 3, right? So it's 1.5 kg meters per second to the north. So I'll put in 1.5 here, north. Like that. Okay? The second guy, momentum 2, right? Flies off in the southwest, right? And it's 0.3 times 4, which is 1.2 kilograms meters per second. And that's southwest. Okay? So now what I want to do is I'm going to solve for the components of this guy and then stick them in here. All right? You guys remember this a bit? Taking some time? A little? Okay, so take sine 45 times it by 1.2, please.
$1.2?
Yeah.
0.849.
0.849. Excellent, thanks. So these are both 0.849 then, right? Because this is 45 because of the southwest. So I put 0.849 kg, or I want the units in there, just not enough room right now. So I have 0.849, and that is in the direction, the horizontal will be west, and 0.849 south, right? Just like that.
Oh yeah, I remember this now.
Okay, so what I'm doing is I'm trying to create my angle to be a right angle triangle. Remember this?
They subtract the 1.5 from the 0.849.
Yeah.
It's the opposite direction.
That's right.
Yeah.
Okay, so then so I'm going to subtract that, right? So 1.5 subtract 0.849. 651.
Yeah.
Okay, so that's north, right? Because that was the greater. So now what I'm going to do
He's running an angle.
is I'm just going to create my new right angle triangle, right? So I've got to the west. Well, I'll do the north first. I like that better. So the north at 0.651 kilograms meters per second. And that's north. West is 0.849 kilograms meters per second. West, right? And then I want that guy right there. And that angle. And that'll give me the momentum. So what I'm finding is I'm finding the momentum, the negative momentum of that first piece. Okay, or that third piece, sorry. Okay? So what I want you to do is I want you to solve this right now. So 0.849 squared plus 0.651 squared, and take the square root of it.
1.069.
1.069 kilograms meters per second.
You get that, John?
So now I want that angle. So take, what am I going to use? I got opposite and I got hypotenuse.
You got opposite adjacent.
Or adjacent, sorry, yeah, 10.
10.
10, right? So second function 10, 0.849 divided by 0.651.
So 46.9.
Okay, so that is the negative P3 prime.
Yeah, plus positive.
So I want it in a positive direction. So my P3 prime is equal to 1.069 kilograms meters per second. South 46.9 degrees. Oh, this should have been west here, not south. East.
I got 52.51 degrees.
Did you take 0.651 divided by this?
No. I did
0.8 second function. 0.849 divided by 0.651.
8.4 over 6.5.
0.651.
Yeah.
That's it. And he gets. Yeah, that's right. I think you did.
How much did you flip wrong then?
No, you did this over this. Because it will give you the.
Okay, yeah.
Okay. So what's this angle then, Chris?
52.52 degrees.
52.52 degrees. 52.52 degrees. Okay? But it asks you to find the velocity of that third piece. So how do I find the velocity of that third piece? I've got momentum. How would I find velocity from it? What does momentum equal?
By
Yeah.
its mass.
Yeah, divide by its mass, right. So what is the mass of the third piece?
Is it 0.3 kilograms?
No. First piece is 0.5.
Oh, you just, the whole grenade. You gotta subtract from the grenade.
Oh, 0.4.
Yeah. So take this number here, 1.069, and divide it by 0.4.
2.67.
2.67 meters per second, south 52.52 degrees. And there's your solution, boys. Okay?
And you flipped the directions because you had that negative in front of it.
Because of this equation right here.
Yeah. Okay.
Yes. Okay, now so that's the right angle triangle way of doing it. When there's a third piece, when there's you're gonna do this question again, this exact question again, they're gonna change the first part of it. Instead of it being stationary at rest, it's gonna be moving. So you're gonna have a momentum before. So this is like question 2 in the next section, I think. You're gonna have a momentum here. So now you're gonna go this value here, subtract that, subtract that. So now, this is why I do the right angle triangle. When I have 3 vectors, it makes sense for this. If I were to do this question again, I would probably not do it using right angle trig. I would do it like this, okay? I've got the negative of this, and the negative of this, agreed? So what's the negative of that direction right here?
1.5 kilograms per year per second south.
South. So I'm gonna draw that first. Okay? So that's exactly right, 1.5 kilograms meters per second south. Like that. What's the negative of this direction right here? So,
Is it already?
so it's southwest here,
So it'd be northeast.
northeast. Right, so northeast, okay? So it's up here. Like that, right? And I've got 1.2 kilograms meters per second, northeast. Okay? And then I would find this guy right here.
Also use,
Close. Because I know that's 45 degrees right there. And that would have been, that's quick.
Mhm.
That's the easy way to do it. Okay? And I would have got the exact same thing here. So you notice this right here? This is south 52.52 east. That's what it's going to look like.
So technically, if we do it that way, we're gonna get the same number as if we tried to,
100%.
like, with the 0.34.
100%. Exact same thing.
wow.
Yeah.
So
Yeah.
we just went an
The only
extra
thing
step.
the only thing that's tougher on this guy, all right, than this is finding that other angle. Which angle is it, and what is. So what you would end up doing is this, using your law of sines, and you would get this. So it's just describing that angle is the tough part. Okay, but it's not difficult because you're just using the law of sines one time and then you're done. Okay, so when I use my law of sines, I'd be saying south and then so many degrees east, which is exactly what that is. Okay, so if I was doing this question again, this is all I would do right here, because there's only two vectors. The moment I put a third vector in, then I like to use this method with this. Okay? Any questions about that? You guys remember how to do those vectors a little bit more now?
Yeah.
Okay, so just looking at page 314, the one thing that you absolutely have to do with these questions, so like you see that first question there, you want to start with your momentums first, okay? So you always start with your momentums and then you work it through after that. So start with your momentum equation first,
Mhm.
and then draw the vectors the way the equation tells you to. All right, so for example, in that first question, you've got two identical balls, so because they're identical, you don't need to use momentum, you can just use their velocities for this, because they're all the same mass. Okay, so I've got V1 beforehand, right, is equal to V1 prime plus V2 prime. All right, it gives you V1 prime after. So what am I going to be finding? I need to find this guy here, right? V2 prime. So what is V2 prime equal to in this equation?
V1 and V3.
V1
subtract.
subtract V1 prime. All right. So here's what I do. Draw your V1. So your V1 is that, right? Sorry, my bad. It is not that. My V1 is moving this way. There's V1, right? Now I want to draw the negative of V1 prime. So right now, this is the way V1 prime looks, right? It's up that way, right? With an angle of 30 degrees, correct? So that's V1 prime right there, but I need the negative because this is what it tells me. So I'm going to draw it like this now. And then I'm going to get, that will be the second wall, right there. Okay? Does that make sense to you guys?
Yeah.
Okay, but it always starts with this. It starts with that equation right there. Sure. Draw the equation write the equation out first, then draw your vectors the way the equation tells you to. Okay, and then number two is this question again, except you got a momentum first. Okay.